Hey guys, if you are here, hopefully that means you passed 0.1. So congratulations, one mastery check down, a whole lot more to go, but you are on your way, which should feel very good. We again are working in this unit 0. Remember on unit 0 there is no test, but there will be a mastery check over each section. These sections should be review, but obviously I thought they were important enough that we are reviewing them just in case you forgot anything. So in 0.2, we're going to talk about evaluating equations. So at the very top on your notes, this is not here, okay? That's going to happen on throughout the notes is I'll have stuff printed out, but then you need to fill things in. And not just work, but sometimes I put the problems in there. Okay, so go ahead and write that in. The equation we're working with is y equals x divided by 2 plus 4. Now problem number 1 says solve for y. And we want to solve for it when x equals 10. Okay? Well, if x equals 10, what do you think we should do with that 10? Hopefully somebody out there, maybe all of you, are thinking plug 10 in. And that's exactly what I want you to do. So y, we still don't know. That's what we're solving for. We're trying to figure out what y is equal to. But when we go to do the right side, we know what x is. X is 10. So we're just plugging it in. Now, you need to remember your order of operations. PEMDAS, right? By the way, how many steps are there in the order of operations? 6? No. There's only 4. Because you do parentheses or any other grouping symbols. You do your exponents. But then multiplication and division are all one step. So how do you know which one to do first? You do it from left to right. Addition and subtraction are all one step. You do whatever comes first, left to right. We have no parentheses in this problem. We have no exponents in this problem. We don't have multiplication, but we do have division, so that's what gets done first. 10 divided by 2 is 5. And then drop down the plus 4, so we get that y equals 9. Yay, that's your answer. Could you check that? Absolutely. Plug 9 in for y, plug 10 in for x, and you should get equivalent numbers on both sides. I'll leave that for you to do. Example number 2. Now we want to, instead of solving for y, we want to solve for x when y is, let's make it 10 as well. Think we're going to get the same answer or a different answer? Hopefully different, because we got y equals 9, and now I'm saying, no, y is 10. And now we want to solve for x. So plug 10 in. So we're still using that original equation, y equals x divided by 2 plus 4. And we're going to plug 10 in for y. Do we know what x is? No, so it stays x. And we're solving this now. Well, this one we really just used order of operations because all we had to deal with was numbers. But this is more like your 0.1 packet where you're solving an equation. So the first thing you want to undo or get rid of is the plus 4. So we would need to subtract 4 on both sides. 10 minus 4 is 6, equal to x over 2. And that means division. How do we get rid of division? We multiply. So multiplication by 2 on both sides gives us an answer of 12 equals x. Again, you can check that. Plug it in. 12 divided by 2 is 6. 6 plus 4 is 10. And we said y was equal to 10. So there you go. You are good. Okay, example 3. Now we want to essentially do the same thing we did on examples 1 and 2, but we're going to complete the table. So we've got a few problems within just one problem. Complete table using the following equations. We have a new one. Make sure you write that in. Your notes, again, they need to be complete. So anything that I have added up here or anything that I write, you need to have. So completely fill them in, including writing the problems down when they're not written for you. All right, so in my table, I also added 4 values. What I need to do is find the corresponding value for the other column. So for the first one, I'm telling you that b is negative 3. So I'm going to plug that in to the equation. So a, we don't know. equals b, we do know it's -3, so I plug that in, I substitute it in, and then this is just simplifying it. Now my order of operations say I should do division, which I have here, before I do addition, which I also have here. Is that right? Should I divide this before I add? And the answer is no, because really this problem also has parentheses, they're just invisible. This big division bar is acting as a grouping symbol. It's grouping that numerator all together. So you actually need to do that part first. -3 plus 4 is +1, and 1/2 is just 1/2. Some of you guys are going to want to divide that out and get a decimal, and hopefully you know that that decimal is 0.5. You can do that. That is fine. However, what's going to end up happening is mistakes. It is better to keep this fraction. Even though I know a lot of you don't like fractions, it's better to keep that fraction. Okay? If you accidentally divide it upside down and you get 2, 2 is not the same as 0.5 or 1/2, so that would be wrong. Or say that decimal didn't come out nicely and you had to round it. That is not an exact answer, and I don't want that. Okay? Fractions are always going to be precise, never rounded. So fractions, therefore, are better. Keep it in fraction form. Okay, the second one. Now I am being told that b is 0. So when I plug that in, I get a equals 0 plus 4 divided by 2. Again, that numerator is grouped, so 0 plus 4 is 4. Divided by 2 gives me an answer of 2. Fill that one in. So both of those problems were like example 1, where I was just doing order of operations, just evaluation. Now, I'm not given the b values, I'm given a values. So plugging a in as -7, and then that's still equal to b plus 4/2. I need to solve for b. This is like example 2 now, where you're actually solving an equation like we did in the last section. Because that numerator is grouped, I don't want to start by subtracting 4. That 4 is grouped with the b. So the first thing to get rid of is multiply by 2. Remember in that 0.1 video we talked about undoing things in the opposite order they were done? Well, if you look at this, what's happening to b? It's being added by 4 and divided by 2. So the last thing that happened to it is the first thing to undo. That gives me -14 equals b plus 4. And then I'm going to subtract 4. Both sides, I get -18 equals b. Fill that into your chart. And one last example, plugging 10 in for a. Again, make sure you plug it into the correct variable. We don't know b. So the first thing to undo is the division by 2, and you do that by multiplying. And we get 20 equals b plus 4. Subtract 4. I'm running out of room here. You get 16 equals b, and we fill that in. So now we've completed our chart. This is also called a table or a T-chart. Okay? So you're just using one value in the column to find the corresponding value in the second column. Okay? Good stuff. All right, so now everybody's favorite, word problems. You are not going to get away from word problems this year, so don't panic when you see them. Hopefully you will get so much better at them this year, it will not even be a big deal for you. The amount of money in Mr. Bean's wallet is $50. Take away $5 for each kid that asks for lunch money. Okay? Well, what are some important things we see? Well, I see $50. I see a number there. I see take away, which seems like what? Subtraction. Let me read that, 50. And I see another amount, $5. Okay. And I also see what we're talking about is the amount of money in Mr. Bean's wallet. So I think we could translate that into an equation. Well, what would the equation be? And then define your variables. Define your variables means say what the variables stand for. The first thing I think we need a variable for is the amount of money. I could call that X, I could call that Y, I could call it any letter I want, but because amount of money starts with an A, I'm going to call it A. So this is defining your variable. I'm writing my variable letter, and I'm saying what it's equal to. It's equal to the amount of money in Mr. Bean's wallet. If you want to write in Mr. Bean's wallet, that's up to you. Okay, so that's the first part of my equation. The amount of money is. Is, by the way, is always means equals. Okay, so if you see that, equal sign. $50 take away minus $5 for each kid. Well, could more than one kid ask for lunch money? Yeah. So I think we need another variable. Because they said each kid, we need to deal with a second variable. So let's say for K equals the number of kids that ask for lunch money. Again, you don't need to put that extra information. It's great if you do, but don't worry if you don't. So what should I do with that K? Should I add it? No, I'm not adding the number of kids to the number of dollars. Well, if 2 kids asked, that'd be what? $10, because that'd be $5 times 2 kids. So times is what we need to do. 5 times the number of kids. And we know if we don't have a symbol, that means multiplication. You certainly could put a multiplication dot there or parentheses, but do not use an X for multiplication. What's an X going to look like in this equation? It's going to look like another variable. So stop using X's for multiplication. We either use parentheses or the multiplication dot, or nothing if it's between a letter and a number. All right, so what's the equation? There it is. There's my variables defined. How much money does Mr. Bean have if he gave money to all 9 of his children? Well, what's 9 represent? The number of children. So that's our K. So we're going to plug 9 in for K. So A equals 50 minus 5 times our K is 9. Well, I need to do that multiplication first. That would be 5 times 9, 45. And A equals 5. Important thing, when you're answering a word problem, you always need to label the units. Put yourself a note here. Label units. I will take off for this. If you don't label your units on quizzes, tests, whatever, particularly tests, I will subtract a point. Okay, so to answer this question, the answer is 5. 5 what? $5. How many children did Mr. Bean give money to if he has $30 in his wallet? Well, it's $30. Where would we plug that in? That's the amount in his wallet. Is that your A or your K? That's the A. So $30 equals 50 minus 5K. Now we have to solve this equation. The variable's in with the numbers, so we need to treat it like the last section. So subtract 50. Sometimes this confuses students because they see this minus sign, so they think, okay, I need to add 50. That negative is with this 5K. It's not with the 50. You're actually adding 50 to negative 5K. So to get rid of add 50, you subtract 50. Then we get negative 20 equals negative 5K. Divide by negative 5. Both sides, whatever you do to one side, we do to the other. And we get that K equals 4. 4 what? It's a word problem. We have to label the units. 4 is the number of kids that he gave money to in order to have $30 left. Okay, good stuff. Hopefully we're making sense here. Student council needs to raise $400, so they hold a talent show and sell tickets. Every student ticket costs $2 and each adult ticket costs $5. What's the equation? Define your variables. All right, let's read this through and see what's important. Well, the student council needs to raise $400, so immediately I see a number. Every student ticket costs $2, each adult costs $5. So I have 3 different numbers we're working with. They all seem important. Then what about variables? Well, what don't we know? We don't know how many student tickets they sold. We also don't know how many adult tickets they sold. All right, let's see. Well, our 2 unknowns, I think we could say S for the number of student tickets sold. And how about A for the number of adults? Adult student, no, not adult student, adult tickets sold. Okay, so sometimes it's helpful to start with what you're actually going to have variables for. Then hopefully the equation will just kind of line up for you. They need to raise $400. That sounds like a total to me. Anytime I have a total, I think about setting something equal to get that total. Every student ticket costs $2, so I know I'm going to have a 2 in here, but that's only for student tickets. So what would I do with the student tickets? I think I'm going to multiply that, because however many student tickets I buy, I have to multiply, or I sell, I have to multiply that by the $2 that they cost. Then along with that, for the adult tickets, I probably am going to have a 5 times the number of adults. And then what am I going to do with those two amounts to equal 400? I'm going to add them. Okay, so there's my equation, and I defined my variables. Please make sure when you're working on these, you do this writing out. You have to write out what your variables stand for. Okay, how many adult tickets do you need to sell if you sell 200 student tickets? So 200 is the number of student tickets, so that has to be the S. So 400 equals 2 times 200 plus 5A. That would be 400 equals 2 times 200 is 400 plus 5A. Subtract 400 on both sides. And by the way, I would prefer that you keep working down, but I'm obviously out of room, so I'm going to move over. 400 minus 400 is what? 0. Sometimes students get a 0 and they're like, oh, it's no solution. I can't do it. I don't know how to do the problem. It's a 0. What? Oh my gosh, what do I do? 0 is a number, just like every other number you work with. So write it. It's 0 equal to 5A. Still have to get A by itself, so we would divide. Well, 0 divided by anything is still 0. So how many adult tickets do you need to sell? 0 adult tickets. You've sold enough of the student ones to make your $400. All right, last one. How many student tickets do you need to sell if you sell 50 adult tickets? So 50 is your A, because that's the number of adult tickets. So going back to our original equation, 400 equals 2S plus 5 times your A, and A is 50. You would need to start by doing the multiplication. 5 times 50 is 250. Subtract 250. 400 minus 250 is 150 equal to 2S. And then we're going to divide by 2. So for S, we get, what's 150 divided by 2? Okay, so 75. 75 what? 75 student tickets must be sold in order to get that $400 amount after you sold 50 adult tickets. I didn't circle that very well. Okay, now comes the point in the video where I say you try this. There's the equation you need and the numbers I'm giving you, and then try number 2. So these are 2 separate problems. I want you to pause the video now and actually try them on your own. And then I will come back in a few seconds here and you will check your work. So pause the video. Okay, hopefully you have done all of these. Check your work against my work. You got 13, negative 21, 7, and then 19 over 2. Remember, I want you to keep that as a fraction. The equivalent decimal would be fine because here it does come out nicely. It's not rounded, it's just 9.5. But 19 over 2 is a better way to leave it. Number 2, sometimes students will say, there's only one number, how am I going to write an equation? Well, all you have to do is add together the number of algebra tests and the number of geometry tests to get the total number. So sometimes that's all you need. You had your 2 other variables and just one number. And then your final answer is 20 geometry tests. Okay? That is all the notes. So remember, the summary is up to you. If something stuck out, you want to remind yourself, that's a good place to write it. And then you can go ahead and move on to the practice problems. Make sure you're checking those 2 ways to do that. They are on my website. Same place you're watching this video, underneath there it says practice solutions. That's one place. And the other place, if you're in class and you don't want to go through the trouble of getting on a Chromebook just to check your answers, I have them printed out. So you can always come over to my desk and ask me to look at one of those. Okay? Good luck.